Problem 1. So Andy and Betsy both live in Mathville. So Andy leaves Mathville on his bicycle at 1:30, traveling due north at a steady 8 miles per hour. So let's say this is Mathville. Um, Andy leaves. So Andy leaves with a speed of 8 miles per hour. And Betsy, right? Betsy leaves on her bicycle from the same point at 2:30, traveling due east. So that's Betsy at 12 miles per hour. At what time will they be exactly the same distance from their common starting point? So what that means is that, let's say this is M, Andy ultimately is here, and Betsy is ultimately here. The distance from A to M, right? This will be X, and here would also be X. So how long does it take for Andy to travel the distance of X? Well, at a constant velocity, d is v times t. And Andy is traveling at 8 miles per hour, and for however long, he has taken. But let's say that they both start out at, well, Andy leaves at 1:30. So let's say he has traveled a t amount of time. Let's just put t, and that's just in terms of hours. Then for Betsy is traveling at 12 miles per hour. And how much time did she take? Well, Betsy left at 2:30, so she left a full hour later. So, however much time Andy took, right, to travel a distance of x, Betsy must have taken t plus 1, because after, right, you can think of it as like when Andy was here, right, let's say he traversed this in 1 hour, that's when Betsy started to leave. So it took Andy this amount of time to traverse the whole thing. Oh, so this should be t minus 1. Sorry, so this should be t minus 1. Okay, so now we can just solve for t and x, and we're done. So we have x is 8t, so 8t is equal to 12t minus 12, so 4t is equal to 12, so t is equal to 3. So it took them 3 hours, or it took Andy 3 hours, took Betsy 2 hours. And at what time? Well, 3 hours passed of Andy, that's 3 hours plus 1:30, so that becomes 4:30. So the answer should be E.